So what I want to look at today, I'm adding one, and this is good news for you. The test is going to be in two parts. There's going to be a non-graphing utility part where you cannot use, go and get rid of that where you can't use Desmos graphing. I'll embed the Desmos scientific calculator. So you'll have that available. That's going to be the harder of the two for sure. That's going to be the one where you're going to have, there'll be two solving linear systems problems. I didn't make them real bad, but you got to be able to solve a linear system. It's mostly going to be solving quadratic equations, right? Using whatever method you think is best, but you're not going to get marked wrong if you use the wrong format. You don't use the easiest one. I just want you to get correct solutions. On the non-graphing utility one, on the graphing utility one, there's going to be a couple discriminant questions, piece of cake. I'll put a couple of, not very many, but I'll put maybe two of the pick the best method problems. But the rest of it's just going to be graphing stuff, right? It's where you can use Desmos to do all the work for you. So you could do, for example, let's just review real quick one of the linear systems problems. So if we go to the 5.4 practice 2, solving linear quadratic systems graphically. So if we go to this guy and we pick a couple problems, like just this one, for example. So let's use Desmos, and let's get an answer to this easily, right? So what do we have to do in Desmos?
Put those in, and it's going to give you the answers.
Yeah, it's really not going to. It's not very hard stuff, right? We're just going to plug in those two equations and see where they cross, right? So if we put in, we have to type it just like that, right? Because this equation, notice that this equation, can you guys see that, or is that too small? Let's make that a little bigger. There we go. Now you can see it for sure. Okay, so if we type those in, both of these equations have x's and y's, right? We don't have to solve for y explicitly. We can just leave the y mixed in there, and I'm going to get so we'll just plug this in exactly as it's written. That's the great thing about Desmos, right? I mean, it's so easy to use, but you're going to use Desmos a lot, like on the SBAC test. You'll get problems like this, and they're freebies. So there it graphs the parabola, right? And we'll make it look better in a second. Then we type y equals negative 2x minus 4, and all we've got to do then is what? Zoom in, right? We just got to zoom in until we can see where the intersections are, and my solutions are that, right? And we're just rounding to the nearest tenth if they don't end up being integers. Okay? Make sense? No biggie. Piece of cake. All right, so that's part of it. Now the other part, I just added this new assignment called Finding Real Solutions of Quadratic Equations with Desmos. Okay? So all it is the same kind of thing, but I just want to go through a couple examples. So if we were to, what am I doing here? I want to preview. Okay, let's pick a little harder one. Pick one like this. Okay, so what do? Let's try this with Desmos. So if I want to put this function in there, look what happens this time if I type in that equation. If I type in the equation, it's not going to
work.
Yeah, it's not going to work. Oops.
You gotta make it work.
If I just type it in like minus 4. Now, so far so good. If I type that in, I get a parabola, right? But when I watch what happens when I put equals negative 1. If I put equals negative 1, oh, never mind. It does work. Okay? So it gives us the graph of that parabola, right?
Did you know it was going to work?
No, I didn't think it would, but it does. Okay? It does. So we just type it in. We don't have to even solve it, right? It just gives us the parabola. And if I zoom out on this thing, we can see that, well, we don't even really need to, but there's our parabola. It's really tall and skinny. If I want to find the vertex, I don't even know where the vertex is. It's there somewhere. Let's go to the, here I'm going to do this. Let's go to, I'm going to change these axes. I'm thinking maybe it doesn't work. So if I go negative 10 to positive 10. Okay, I'm still not, boy, that's, man, that thing's, where the heck is the vertex on that? Okay, I'm not convinced this is working. I'm not convinced it's working. So all we have to do, though, now we don't have to do anything fancy here. If I wanted to put this into standard form, I don't even have to combine like terms. What's the one thing I would do to get this set equal to 0? I would add 1 to both sides, right? So all I've got to do is take the function on the left side and just add 1 to it. Yeah, see, it wasn't working. And what do I get? I get that parabola, right? All I'm trying to do is if I'm trying to find the zeros of that function, they're the x-intercepts, right? You get that? So if I put everything, if I just move all the terms to one side, then I'm graphing a parabola and I'm just looking for the zeros. That's it, right? So what would my solutions be? So in Moodle, we would enter
0.5.
Yeah, I'm just entering. I'm entering negative point. I'm rounding to the nearest what? Rounding to the nearest hundredth. It looks like. So I would get. And I'm going to change those to say tenth, I think. But for now they're hundredths. So I would get negative 0.65, comma, and then 4.65. See how easy it is? Piece of cake, right? Nothing to it. Let's go down and try like a hard one. So that's got fractions, yikes. But it's no, what am I going to do? All I've got to do to put that all on one side is do what? No. If I just want to get everything on one side, add x. Add x to the left side, right? So in Moodle, all I'd have to do, there we go. All I'd have to do is just change this to 3x squared plus 7x plus 76 thirds plus x, right? Mm-hmm. So there's my parabola. Now I just have to go find the x-intercepts. So if I zoom out, are there any?
Would it still work if you wrote plus 8x?
If I did what?
Plus 8x instead of having like the extra x in the end?
Oh yeah, it would. Of course. Yeah, it'd be the same thing, right? Let's graph those next to each other. So if I go down here in a different color, let's graph 3x squared plus 8x plus 76 thirds. Same thing, right? Notice they overlap perfectly. My point is just that you don't even have to go through the hassle of adding up the like terms if they're fractions or something weird like that, right?
So set it equal to 0.
Right. So we just have to set it. We have to write whatever is set equal to 0, and we're looking for, by setting it equal to 0, we're just asking when y is 0. So what are the x-intercepts, right? So we're just looking for the x-intercepts when we get the expression that is set equal to 0, right? So what about this one? If we look at the directions here, it says if multiple solutions exist, separate them with commas. If no real solutions exist, enter false.
Enter false then.
False because there are no x-intercepts. So there are no real solutions, right? Has to be lowercase. and it'll turn blue. See, now the computer recognizes that as a possible answer, so it turns blue. And it's right. Make sense? Okay, we good? Go. You can work.